This meeting
Hello,
is being recorded.
Hello, it's September 19, 2023. Uh, it's a sidecar working group meeting. Welcome, everybody. Let's get an agenda. Genjo, you go first.
Yes, I listed those PR just to ask for the reviews because they they should be merged before we go to the beta stage.
Okay, so this is mostly about like resource managers, all sorts of resource managers, right?
Yes, most of them are resource managers, and one thing is about the previous regression, like start init containers in the right order.
Okay. Is there any
Even with sidecar containers, yes.
Is there any concerns from Francesco? Or Francesco is fine.
Yes, I think they are all okay.
Okay.
Yes, and also I'd like to add the working group sidecar label to the Kubernetes to find the related PRs or issues easily. Can we do that?
We can suggest. I don't see a reason why not. So yeah, let's make it going. Yeah, just yesterday I discussed with Wojtek about tracking issues. We have similar problem for in-place upgrade cap. We have so many issues that it's really hard to query them all.
Mm.
Okay, so work group sidecar sounds good.
Mm.
Maybe label will be different. Let me ask who can do it, and I know mechanics of it, but I don't know like who needs to approve it.
Okay.
Good suggestion. Okay. I see you looked at the PRs already, right? Most of them.
I don't remember. There are so many, and yeah, this week I didn't quite work on these. So yeah, I should probably take a look if you want.
I can help out a little bit from review point of view because these are resource management specific, so I might be able to help out.
Thank you, Swati.
That would be great.
Thank you.
And that's it. Swati, do you want to talk about your topic?
Yeah, so this is kind of an issue that Paco had created, and it's related to the ability of allocating CPUs exclusively at a container level. So currently, CPU Manager, if it's enabled with its static policy, looks at the quality of service of your pod. And then if you specifically indicated through integral CPU request, that's only when it ensures that CPUs are exclusively allocated. So I think what Paco was requesting was that we have the ability for a container to be observed or evaluated independently of the overall quality of service of the pod. And I had some potential solutions to get to, a way of achieving that. So I left a comment there, and if you scroll a little bit more, I think you should see it. Yeah, that one. I think you just scrolled by. No, I'll share the link. Yeah, the one before this. Yeah, that one. Yeah, so this basically talks about a new kubelet flag. So we can something like a CPU manager scope. And this is very similar to what we have with topology manager. We have a topology manager scope. And this would allow us to evaluate a container independently and kind of independent of its cause. So that was the main idea. In addition to that, we would need some changes in the resource requirement spec itself, which is essentially, you'd see that in pod spec, and you can see the example below, which I have there. So we can introduce something like a resource constraint, and then we can say that for a specific resource, we have this constraint. And I want to have this as a very generic solution and not just specific to init containers, because I've seen a lot of other use cases for this. So I just here to discuss that and get a sense of how everyone feels about this, if this is something that should be pursued in 129 cycle.
First of all, it's not something I'm thinking about every day, so I still need to have some time to absorb the suggestion. The suggestion is, I know in topology manager scope maybe either pod or container, but if it's container, then you only look at container level. You cannot say these two containers you look together and other containers you look separately, right?
Yeah. So at a pod, so in this case, the way I envision this is, if we have a CPU manager scope as pod, we would default to the current behavior, and that would allow us to get the backward compatibility that we obviously need. And the container option is going to give us the new feature or the capability that we want. So we look at the container independently. The only problem, which is something that I've highlighted in the end of this comment, is that we want to ensure that the container, or rather the pod in general, has guarantees around exclusive allocation. So, now this container is requesting for exclusive allocation, but because it's not part of a pod that is guaranteed, it could be evicted by a pod that is guaranteed. So we want to give these kind of pods more priority. So one way of handling that is that we change the quality of service evaluation logic and take these kind of containers, init containers, into consideration that are explicitly indicating that they want exclusive CPUs.
Okay. And is it a scenario when all the main containers want to share CPU and sidecar is working on some shared pool of CPUs, or it's not a scenario?
I think at the early stage, I haven't thought about a separate shared pool, if that's what you're asking about. The way I see it is like we have a shared pool and then we have exclusive CPUs. So a container that's requesting exclusive CPUs would be getting exclusive CPUs, and everything else would be in the shared pool. So there's no
Yeah. But
separation of shared pool.
can I ask for all the main containers to share the same CPUs inside, like, because I see sidecar is a little bit different beast. Often sidecars don't need access to the same memory or same CPU or same devices because they simply provide some networking or logging functionality that doesn't really need to be there. It only needs the same file system and same network as other containers. It doesn't
Yeah,
want to know about resources of other containers.
but that's precisely what containers that don't have exclusive requirement get. So this is exactly, for normal containers, we have the same requirements. So imagine a pod that has two containers. One is that is running busy loop or DPDK application, and the other container that is just doing some sort of logging. So essentially, for the second container to be on the shared pool, it doesn't really care, what exactly is the shared pool, as long as it's uh, a group of CPUs that don't interfere with exclusive. And we mainly care about exclusive CPUs that are allocated to pods that are explicitly expressing that requirement.
Yeah, I think this feature will be very valuable. The way you explain it. Is there any other questions?
No, yeah, I think the key question is like, do we go ahead with this in 129 timeframe?
Oh, yeah,
It's
I
going to
mean, if
be,
anybody else has a question to you, but yeah, I mean, our main motivation for sidecars, like there are many reasons why you need sidecars, and Istio is exceedingly moving to eBPF approach, and we have different stories there. But what we see more and more is all the AIML workloads, they want to be resource efficient, and they need all these resource managers because of device access, and they need logging and monitoring, and that's why sidecars became more and more interesting to community. So
Absolutely.
from that perspective, I think this is important feature, and if it will be in 29, it will be great. Now the question is, uh, like I see two APIs. Like you want to introduce two APIs, right? First API is a kubelet flag, and second API is resource constraints.
Correct. Yep.
That may
Which is
be,
going to be, yeah, that's going to be challenging. Yeah, and I understand that. And actually, one more thing that I want to point out here is that I am intentionally trying to keep this generic. So the solution is not going to be specific to sidecars. This can
yeah.
be this is going to be applicable to any container that specifies this resource constraint, and it would depend on how the node has been configured. So that's very intentional, because I've seen in the code that a lot of places when we are evaluating containers, the first thing that we do is append normal containers to init containers, and then we evaluate them. And I just want to make sure that we continue to respect that. So that's why I want to have this as a generic solution and not just specific to sidecar. I totally understand that this is important to sidecar, and that's why I'm kind of having this discussion here with you all.
Yeah, it makes sense. Yeah, it may be challenging for 129. Anything related to resource utilization can be challenging. So can you explain again what resource constraints do?
So, currently CPU manager looks at the quality of service of a pod,
Mhm.
and if we have, so for example, if you look at the first container here, um, it would look at integral CPU request, but the overall quality of service of this particular pod is burstable. So the CPU manager would actually not even allocate exclusive CPUs for the first container. So that's essentially the problem that we are trying to solve. So what we are trying to do is make this requirement explicit, as opposed to earlier it was implicit. If you have a guaranteed quality of service pod and integral CPUs requested within the container, only then it'll be allocated exclusive CPU. So it's like you have to go to CPU manager documentation to figure out how do I actually request exclusive CPUs. With this, we would be making the request more explicit.
Yeah, we
And
had
I
similar
believe,
problem. Yeah, we had similar problem with swap cap. So in swap cap, we wanted to make sure that customer can disable swap, because swap, like, first it has security problems, but also it has some performance issues. So what we said is, if pod is guaranteed, then we will disable swap for this pod. But also we said that if um, container is guaranteed, and guaranteed is meaning that memory limits and equal memory request, then we also will disable swap. So we didn't put an explicit API there. We just said that implicitly we will look at your container and decide per container, kind of, is it guaranteed or not to
yeah,
have memory.
but I think swap is still in a better position than we are with CPU manager, because
Yeah.
we don't evaluate a container based on, the quality of service of the container itself. Like with swap, say at a container level, you are able to disable swap, but here we are stuck with what we get as as a package of pod as a whole.
Yeah, actually, that this relates to one question that I had. Since you're making something implicit explicit, is it possible to make mistakes or something that don't make
Yes,
sense?
absolutely. So I did think about it a little bit. So the the mistakes that you could make is, for example, if in the first phase we are just doing this for CPUs, like the API allows us to specify something like a memory, within the resource constraints, but that's not supported. So we would need a validation admission hook to make sure that, that the spec is validated. Then the other aspect that we would need to handle at kubelet level is a scenario where, by default you have pod scope, which is current default behavior, and then all of a sudden a pod comes where resource constraints are specified. In that case, kubelet would be rejecting that pod at admission time because it doesn't make sense. This particular node is not going to be able to support this configuration. So those are the two main scenarios that I've thought about, especially with relation to inconsistent configuration or behavior. But if there's anything else that you can think of, like definitely.
Maybe mathematics, like if you have like container constraints that add up and exceed the pod constraints, or I don't know if it's even possible.
Yeah. So I think the way I would see is that the resource constraints corresponding to a resource would have to be identical to what has been specified with resource request and limit. Because if that's not the case, from scheduling point of view, we are not going to be doing the right thing. So that's going to be important as well. So that is another constraint that we would have to perhaps handle in the validation webhook.
Yeah.
On that second container there, what is that resource constraint doing for that container? Is it just a no op? It doesn't do anything?
Exactly, yeah. So the intention here is that if you don't specify the resource constraint at all, or you don't specify, like, say, the exclusive field or the resource corresponding to it, it'll be a no op, and the container would get CPUs from shared pool. So it's going to be kind of an optional field.
And so on that first one, if like you change it to a 1, I guess like, what there's a mismatch between that value and what the pod actually requests.
Yeah, that's exactly what I just said there. So we would have to make sure from validation standpoint that we have the request and limit matching what you've indicated as the value of the exclusive counterpart.
So I'm just curious, it might be, and this is really, I guess, API design, and I'm admittedly not great at it, but like exclusive just seems like if it's not really even needed, just if it's in the list, if the resource is listed, then that resource is exclusive, and then you can't.
Oh, I see you're kind of getting towards maybe a Boolean kind of semantic. Is that what you're trying to say here?
Yeah, just if it's listed, then then that resource is exclusive, and if it's not listed, then it's not.
Yeah, so I think one of the reasons I went this way was because in the API documentation, they kind of tell you to not have Boolean fields. So one was that. And the other reason was that, down the line, we might want to add a shared field to this, and we might want to split resources between exclusive and shared. So having kind of this laid out explicitly makes a stronger case rather than a Boolean capability.
Yeah, having API discussion here may not be ideal. Yeah.
So I think what I'm going to do is, Sergey, I remember you had shared on Slack the planning document and a separate section. So I've added this to that, and we can maybe write up the KEP in the cycle, see how it goes. Again, priority, I leave it for the SIG to decide, but we can maybe start working in this direction. If it doesn't get in 129, that's okay. We can maybe work full throttle in 130, but I think having one round of discussion as part of 129 would be useful.
Yeah, that's definitely will be helpful. And as I said, it will be very interesting for sidecar customers, for many of them. Yeah, okay. Yeah, I have more questions, but they are too specific. So yeah, let's
feel free to leave comment on the issue itself, because I'm currently thinking about how do I go towards the next step, and I'm trying to make sure that I have all the edge cases tackled, like some of the discussion that we already had about inconsistencies, about values not specified in a proper way, handling misconfigurations and things like that. All those are the type that I'm thinking about already. But if you have like specific questions, that's great. I'm looking for actually specific input.
Another big area to investigate is if customers already have NRI plugins, whether we breaking anything. Because this split brain situation when some decisions are made on NRI, some decisions made on kubelet is not ideal. So if some decisions are made on NRI, they may not know about new way how everything will be how
Yeah, yeah, I was thinking a bit about NRI plugins as well, and perhaps even interaction of NRI plugins with DRA, because DRA provides us the user interface and we can use NRI as a mechanism of implementing, actual CPU allocation. But one of the challenges with that, and like based on discussions, I've learned that when people want to use NRI plugins, you're kind of taking control of the resource allocation completely. And you would potentially be disabling CPU manager and all these resource managers
okay.
in
So basically,
kubelet.
we would disable it completely, and that's why it's
Yeah, I think that's how I would see it. Otherwise, we would need some sort of separation of resources, some resources that are handled by kubelet and some that are given to some other component. It doesn't have to be, it could be, a CPU plugin that I choose to implement using, say, device plugin API. That's something that Nokia's CPU pooler has done. So those are the kind of semantics you separate resources in general within a node. But I don't think we are in the shape or the ability to do that yet.
It makes sense. Okay. So yeah, let's continue discussion in a bigger forum. Okay, for this PR, for this meeting, Todd, you have 2 PRs.
Yeah, I was just putting them on the list. There's 2 more PRs that need reviews, or at least if we're going to go with that label them so we can sort of identify these. Oh yeah, nothing
Okay,
really
this is the old one, and this is the implementation of what Matthias wrote. Okay.
So it's slightly different. There was a comment from JP Betts on that one, and the difference is that this holds the SIG term. Basically, if the pre-stop never finishes for a sidecar, then you won't get the SIG term, basically. So it sort of behaves like normal containers do if your pre-stop lasts forever. But if your pre-stop terminates early, then your SIG term won't come until the main containers are done, or if your pre-start lasts too long but still has time, basically, then your SIG term will come after your pre-stop is done. If that makes sense.
Oh, you're saying if pre-stop is too fast, then SIG term may not be when you expected it.
If your pre-stop occurs is like really fast, you still won't get SIG term until the main containers are done.
Mhm.
But if your pre-stop takes forever and never exits, then basically you just get a SIG kill at the very end because you've consumed all the grace period. I think what Matthias had written up was that you'll get the SIG term regardless of the status of your pre-stop. If it was still running or had exited, you would get it regardless. And so this sort of works the way that normal containers do, which is if your pre-stop runs long, your SIG term is delayed until it's done.
Okay, I think it's easier to fix the documentation than to fix the code. So yeah, I will modify it.
Wait. But we are breaking scenario, right? So our scenario was that
No, we don't.
so if I want to implement Istio, I want to start pre-stop and wait for main container to complete, and then when main container complete, I exit the pre-stop like by SIG term. So I want to exit immediately. So I want to wait till all the main containers still running, but then once they complete, I want to exit immediately.
So
the pre-stop inhibits the SIG term, right? That's the issue.
Yeah. So the way you would do it is that you basically exit upon SIG term. Pre-stop lets you do whatever you want to do, like ahead of sort of get ready to shut down, and then SIG term is the actual shutdown signal.
Yeah, but if I need to do something in pre-stop, like some kind of best effort cleanup, then I cannot do it, right? In this scenario, because if I do it for too long, then I will miss a SIG term and will force pod to wait for entirety of graceful termination.
Yeah. That's not ideal. And if we want to implement the way we documented, that's complex.
It's more complex. Joe had a comment on that one. Find your PR. Yeah, this one. I think it was the very last comment. Yeah. And so we can change it. I have to think about it for a while, but I'm sure it's possible to change it to match the docs. Just want to ensure that that's what we want first.
Yeah, let me reply back here, and we can discuss whether it. I really want to keep this scenario. I want to make sure that we can exit as fast as possible, but allow as much cleanup as you want. So you need to be able to
agree.
clean up as much of cleanup if you want, but then you should be able to exit, to know when to exit immediately.
And avoid misbehaving pre-stop hooks, which could be possible.
That's
I guess,
yeah.
It depends on, are you using the pre-stop to clean up, or are you using the pre-stop to signal to your main process to start cleaning up? Because if it's the second, then it's sort of, it could work. But if you're actually trying to like do the cleanup in the pre-stop hook, then yeah, you've got hopefully
we can achieve the same behavior, but by having pre-stop extremely fast and only use it as a signal.
Yeah. So pre-stop is like kill with whatever SIG user one, whatever signal you want to care about, or touch some file, or whatever mechanism you want to signal to the main process, which then has from that time until it actually gets the SIG term. But happy to also rework this to work the other way. But I think it is more complicated to make SIG term interrupt pre-stops.
Okay. Yeah, and then changing semantics. Yeah, so we still maybe in this pickle situation when we just missed a little bit the SIG term because of pre-stop, and then wait for entirety of graceful termination. Okay, let's discuss in the PR, in this documentation PR, and then adjust implementation correspondingly. Okay, is there anything else?
So Sergey, you will add the comments there?
Yeah, I will add a comment, but please feel free to chime in. I think I don't know how to decide between pre-stop just being used as a signal and exits really fast versus and this is a legit implementation. It also doesn't change semantic of pre-stop, which is good sign, right?
It doesn't, but it's dangerous because it opens the door for misbehavior. So
yeah, so if I implement logging sidecar, then I want to clean up, and then I will wait for termination, and it's unclear how to. So let's say I want to clean up after a last container exited, and I also want to clean up, like start clean up buffers when pre-stop was sent to us. I guess you can still do that. Like you can still have a super fast pre-stop, And then on SIG term, you will start cleaning up for you.
Yeah, I guess for like a login sidecar, I think I would assume that most implementations the login service, like you don't have like a separate login binary or separate like execution that you run to actually go sync stuff off the disk or sync stuff somewhere else. Like basically you're using the pre-stop to signal the primary binary that's running to go do something special. But I don't know. It could work either way.
Yeah, some people just run separate Fluent bit as a sidecar. Okay. Let's discuss in the comments. We may need to extend the description of all the scenarios in a text of cap as well. Okay. Yeah, if nothing else, let's finish the meeting and move into reviews and discussions. Thank you.
Thank you very much.
Bye.
See you. Bye-bye.
See you.